welcome to this Dev Dojo course on Introduction to LLMs and AI Agents. I'm Lucas, I'm your instructor, and I guess most people welcome to Mercari. I guess everyone has been here for like a couple of weeks already. Is that correct? Some people nodding. Cool, nice. So let's get started maybe. First, let me do like a self-introduction. I'm called Lucas. I'm from Germany originally. So yeah, and I joined Mercari in 2022 as an Android engineer. Essentially, I joined in the design system team, and then I switched around between the design system team and the mobile architecture team for like a couple of years, I would say, back and forth. But I continued working as an Android engineer, and since this summer, I've been part of the AI task force. I'm not I guess I'm not sure how familiar everyone is with the AI task force. Essentially, in the summer, the company noticed that, oh yeah, AI is kind of coming up as a theme in the industry, and we want to make sure that we kind of set up for that or try to adopt it as much as possible. So they created like its own small department that looks into like business processes and these type of things. Just kind of analyzes what the company is doing and see where we can apply AI. So I'm working as part of that. I'm working as an enabler, which essentially means like an engineer. So just like trying out small POCs, what can be done. In my case, specifically like in development processes. So like as kind of engineers, how can we use AI? Yeah, so that's my job for the last 3 or 4 months or so. So yeah, by training, I'm just a normal engineer. I'm not an ML or AI engineer or anything. So I'm doing more like applied AI. I still have some slides about like in general, like how these models work. But yeah, I'm not like super much expert on this, but I think it's a good idea to have like a basic understanding of this when working with it. So this course, I think is like 1.5 hours long roughly. So the presentation part will actually be quite short. I think it's just like 15 minutes or so roughly. And then we have this like hands-on exercise where you're going to use OpenAI's agent SDK. So essentially use an AI agent and try to make your own version of something like Claude Code, some like AI coding agent. So yeah, I think I sent you the setup instruction on Friday. I hope people could like run through them if possible. Otherwise, like just do it directly after the presentation. Yeah, I hope it worked out. So then you can kind of get started working on this. Cool. Let's talk about that later. So let's do like the presentation first, just to get like a basic alignment on how these like things work. I think a lot of you might actually already know some of these parts from like university and so on. So we, yeah, we'll just run through it quickly, and then you get to work like on your own kind of project, like dabbling around with it. So yeah, first of all, like what are large language models? Essentially, they're like machine learning models that handle natural language, or like originally, that's what they're doing. Nowadays, I think ChatGPT, they can like handle like multimodal requests as well, like they can generate images and so on, but they're like specialized in handling language. And these are kind of, I think of the new breed of like AI systems, this is kind of the base of all of them. There's some like other AI systems as well, like other like approaches to it, but essentially when we talk about AI, we usually talk about LLMs. Yeah, essentially the main thing is they're trained on like vast amount of text to get this kind of capability of like language understanding. Essentially, during the training process, they have like 2 steps. One is called the pre-training, which is essentially get some understanding of like how language work and like grammar and these type of things, how to form sentences. So they get like, usually these like AI companies, they just scrape the internet for like large amount of text and then train these models so they can generate like meaningful grammar that people can understand. And then they have like a post-training phase, which is somewhat training for specific tasks. So for example, like if you go to ChatGPT and you ask it, I don't know, about some like medical question or something like that, it's giving you like a somewhat reasonable answer, right? So from the pre-training, you wouldn't get that type of answer. You just get some like additional text kind of generated, maybe related to that thing. But in the post-training, really, these AI companies, they train the model to be good on specific tasks. So if you have like a question about medicine, so it actually gives you an answer that helps you, right? Yeah. The other point is that they operate using tokens, so they don't actually operate on text by itself, but on numbers, if you want so. So tokens are essentially somewhere between like words and characters typically. So typically multiple characters together, and they would be mapped to like a number, which then the model processes. Yeah, the exact process how these like tokens are mapped depends actually on the model. So you would have to like look it up depending on the model that you use. I linked like the OpenAI tokenizer here, where you can kind of get an example. If you open that link, you can like put some text in and see like what kind of tokens it maps to. And finally, these LLMs, they essentially, if you run them to get some sort of like result from it, if you evaluate them, then you give it a sequence of tokens. So like, essentially, you can take a sentence and like map it to all the tokens. That's the input to the LLM, and it will give you like a single token as an output in like one iteration of the run. So that single token is not really very useful, I guess. It's just like a number or like a bunch of characters. So you would essentially, to get a meaningful response, you would like run the model over and over again, and then hopefully it will somewhat form a sentence to you in some way, depending on its kind of internal wiring. So essentially, you give it the initial question would generate you one token, then you concatenate the initial question with the one token, run this again as the input, and then gets the next one, and so on, and so on, and so on. So then you essentially, eventually you have the initial question and then your answer. That's essentially how they work. But as you can probably imagine, there's also some limitations these models have. Essentially, they're like very hard to train, or it takes a lot of energy and like essentially power as well. So they just like trained at typically just trained in one point in time. So maybe these like, I guess OpenAI, you can sometimes see it sometimes like when the model is actually dated at some point. So they just train these models and then at some point release one, and then you pass like another year and then they release a new model. So yeah, there's some limitations of this. One is there's like this this knowledge cutoff. So like once the training ends, that's kind of what the knowledge, like the model has a bunch of knowledge like internally kind of encoded, but once you have the cutoff, once it's released, like it doesn't get updated. So if you have any new releases of like, let's say some libraries you want to use while coding or some like new discoveries or something, it won't be in there. The other really important point is that there's like a lack of memory. So if you run the model will still be static. So if you run a question and get your answer, it won't actually change the model in any case. So the model itself won't actually remember what you ask it to or anything. So any sort of like approaches to memory, they're like done using other things, usually through something called like context engineering, I guess. Yeah. Those are the two main limitations. The third one is that obviously these models, they're not trained on any internal data because OpenAI doesn't have access to like Mercari data. And it doesn't know the latest data, right? So the real question is inside companies is how to make these models useful. So for that, essentially what people noticed at some point was something called, these models support something called in-context learning. So essentially it's what you probably do all the time already with these models. If you, let's say, ask ChatGPT, if you can give the model a bunch of data about or a bunch of data or like something that you want it to work with, for example, some document, and then you can like give a prompt at the very end to, let's say, like summarize that data or do some processing of that data. And the model will actually understand that this data that you passed it in and use that also for your answer. So you can, yeah, paste a bunch of document and then ask it some question about the document. It will actually use the document to give you the answer. So it won't just be the internal knowledge. So that's in context learning, and it's kind of the most basic way to make these models work with data that's not actually saved in the model. That was kind of the first approach. Then people kind of noticed that thing. So that's kind of working. So how can we scale this better? So there's something called RAG as well, which is called retrieval augmented generation, which is a more like generalized approach to in-context learning. So if you want to be able to ask a model a more generalized question, there needs to be a more generalized way to provide this like extra context. So yeah, essentially people use some special databases to be able to fetch relevant context for for a specific prompt to then prepend it to the prompt, and then the model can work with that data to answer your question. So these are the two basic things, I think, to incorporate internal data, or in general data that's not in the actual model. The other thing that came about maybe at least since this year, and that actually enabled a lot of things, is something called tools, which is, you can imagine it just like calling a function, like the LLM can call a function just in programming. So it can call a function with some parameters, and then you can give it back a result, and then the LLM can work with that result. So with these functions, if you provide these tools to the LLM, it can actually just fetch the data by itself, or fetch any data that it needs by itself. So with that, you can kind of make it a little bit more like flexible to be able to work with data. Yeah. Those are the main methods to use, like essentially internal data or like any sort of third-party data within these models. So tools are really like the main mechanism nowadays, I think, for like how models interact with the environment or like third-party data. Yeah, so I think what I mentioned mainly right now is that they can fetch data that they can use for processing. But the other cool thing about tools is that just like any functions, it can actually change the environment as well. And that really enables like a bunch more other things. So for example, you can write a file in like Cloud Code or so. It has a tool to write a file, so that can change the environment and can actually act and not just like give you some sort of information. So yeah, how do these LLMs actually call a tool? Essentially, they cannot by themselves just call a tool. They don't have a concept of functions. But the way it works is they essentially just generate some specific sequence of tokens that encodes the tool name and then the parameters that are needed for this. So they give it back to the user. The user will actually have to call the function and then give back the result. And then the LLM can like continue processing to get the answer. So AI agents then, I don't know, I think there's no like comprehensive definition of them, but essentially I got this one from IBM. Essentially, they're an artificial intelligence agent is a system that autonomously performs tasks by designing workflows with available tools. So essentially, once you have LLMs that can have some sort of capability of thinking, plus these tools to interact with the environment, you already have like AI agents, and that's kind of it. So any sort of AI agents is essentially this combination. So as examples, for example, Cloud Code, Codex, these type of like coding agents, they do exactly that, and they're very simple in that sense. And nowadays, I think like ChatGPT even is essentially agentic because, as I said, it has the knowledge cutoff, so it needs to actually search the internet using tools as well to get like more relevant information. There's another word I think that that's kind of big in the AI world, which is called MCP, or at least like maybe a couple of months ago, everything was about MCPs essentially. But yeah, I don't want to go into details on this because it's very simple. Essentially, it's a way to provide tools to LLMs in a more like a plug-in way. So if you install an MCP into your Cloud Code, that MCP's role is to just provide a couple tools for the LLM to call. So examples are like, there's a bunch of like Atlassian, like whatever you use to like connect to Jira. If you have that MCP installed, it can call tools that can interact with your Jira, like for example, create your ticket or like fetch some information for a ticket, and so on and so on. In theory, there's some more things that can be included in MCPs, like prompts and resources, but I think most coding engines actually don't really support that, so essentially we only use it for tools. Yeah, and then finally, AI tools at Mercari. The first thing I want to say is that if you use AI tools, typically, the data that you use with the AI tools will always be sent to some sort of third-party server to evaluate using the model. So a lot of these companies actually store the data as well for at least a while. So every time you use an AI service, you need to make sure it's like vetted by security so that we don't leak any internal data. I linked like a spreadsheet where like all the approved tools here are. So please make sure before you use anything, especially with confidential data, that like it's vetted. The same is true for MCPs. I also linked a list of like approved MCPs down there. yeah, essentially the same holds true for them. The other thing I want to introduce is, or maybe you already know, is something called light LLM, which is very, very useful if you deal with or like want to create like AI agent systems. Essentially, it's just a wrapper around these like LLM APIs. So let's say you have a bunch of companies doing LLMs like Anthropic doing Claude, and then OpenAI doing GPT, and they have like slightly different APIs. But LightLM provides a wrapper, so you can call any of these models and like switch it easily using the same API. So it makes it very easy to develop these systems. The other cool thing is like it's very easy to get like a token for this and like have some central billing system. So typically, if you start like dabbling around, like creating a new system or something like that, you would like use Light LLM, get a token for that, and then just like get going with that. You can easily switch models and so on. So we're also going to use that in the exercise essentially. And that's kind of it from presentation essentially, just the introduction. And then we can move on to the hands-on session.